All right, for this next part, we're going to take a graph or a set of transformations, and we're actually going to write our function. So example 5 says function f was transformed to create function g as shown in the graph. What is the equation for function g? So function g is the solid line. Okay, we can see because it's put a g next to it. So we're trying to write what the rule is for that function compared to the dash line, the parent function. So first thing I like to do is I like to see if there's been any translations, if we have moved the vertex to a new place, because a translation is the only thing that's really going to move that. And so originally our vertex was at 0, 0. Now we have moved down by 3, and we have moved to the right by 5, because my new vertex is at 5, negative 3. All right, so with my function, my new function for g, it's going to need to show those translations. So remember, a horizontal translation happens inside the parentheses. So that means inside the parentheses, since I moved to the right by 5, I've got to say x minus 5. Remember, horizontal translations are the opposite of what you would think, the opposite sign. And then since I needed to go down by 3, that needs to be on the outside of the parentheses. Moving up and down happens outside the parentheses. And of course, I need this squared because this is a quadratic. This is a U shape. All right. Now, the next thing is trying to figure out if something needs to go here. All right, outside the parentheses. I didn't flip over, so there's no reflection, so I don't need a negative out front. But I do need to see if it needs to be multiplied by a number. And so that's when I check to see if this is wider or narrower than the original. So on the original, starting from the vertex, I could go up 1, over 1, and be on my line. On my new one, if I start from the vertex and I go up 1, over 1, that's outside of my line. So my new line is skinnier than the old one. All right, it's been narrowed. Okay, so that means I have multiplied by some number that's bigger than 1. So the way that we can figure that out is we're going to pick a point on our new line. So let's say I pick this point right here. That's at 6, 1. And what we're going to do is we're going to plug it in to this function, and we're just going to use a to represent whatever this number is supposed to be. Remember that g of x just means y. All right, so if I'm plugging in my point, I've got 6, 1. X is going to be 6, y, or the g of x is going to be 1. And this is how I'm going to find my stretch factor. So I'm going to take my function, instead of a g of x, I'm going to write a 1 equals a parentheses, instead of x, I'm writing a 6 minus 5, close my parentheses, squared minus 3. And so I'm going to solve for a. I'm going to get a by itself, just like I used to solve for x. So I got to simplify this a little bit. First, I'm going to figure out what this mess makes right here, the 6 minus 5 squared. So 6 minus 5 makes 1. And then 1 squared, 1 times 1 is just 1. So this is just a times 1, and then we still have that minus 3. Okay, and then a times 1 is just a. So now my next step is to get rid of the minus 3. So I add 3 to each side. That lets me cancel that out, and that gives me 4 equals a. So the number that I need to multiply to make this work is a 4. And so my function is going to be g of x equals 4 times x minus 5 squared minus 3. We could also write that in that true kind of function notation where we use the g and the f to represent that parent function. We could say g of x equals 4f of x minus 5 minus 3. Notice when we write it with a g and an f, we don't use that squared. We don't put that exponent there because f of x is representing the x squared. right? And then to check yourself, we can graph this using Desmos and see how it looks. So pulling back up my Desmos, I'm going to get rid of what I had here. I've already got my parent function in for my first line. I'm going to type in my other one, doesn't matter which one I use, 4 times x minus 5 squared minus 3. And so if we look, we're looking to check to make sure that this matches what we had in the picture. And so we can see that that vertex is at 5, negative 3 where I wanted it. Looking here at 6, 1, we've got it's going through there. And everything looks right. It's narrower than it was before. We're good to go. All right, and so let's look at example 6. Function f was transformed to create function g as shown in the graph. What is the equation for g? So same idea. So let's identify what's happened. So first thing I notice right off the bat, this has been flipped over. This opens down. So that means I'm going to need to remember to multiply my function by a negative for that to happen. Looking at translations, originally my vertex is at 0, 0. To get to my new vertex, I have to go up by 2 and left by 3 because my new vertex is at negative 3, 2. Okay, so I've got those happening. I also need to check to see if I need to multiply by anything, if this has gotten wider or narrower. So remember, on my original, I could go up 1 over 1 and be on my line. On my new one, it's been reflected, so I'm going to go down this time. But if I start on my vertex and go down 1 over 1, I'm on my line. So it hasn't changed its width, all right? It's still the same width across. We did not stretch or widen. And so when I write my rule, I just need to show that it's reflected and translated. So my new function g, we need to have the negative out front to show that it's flipped over. And then since I shifted to the left, that means inside parentheses, I need to say x and then plus 3 since I went to the left. Then I'm going to put a squared because I haven't used an f here. And then I also went up 2, so I got to put plus 2. So that's one way to write it. Or I could say g of x equals negative f x plus 3 plus 2. All right, both of those are correct. So we can go over to Desmos and we can double check how we did. Okay, so I'm thinking it's going to be negative x plus 3 squared plus 2. And so looking at those two, it looks like everything's going to match. My vertex is at negative 3, 2. And then if I look down here, I've got a y-intercept at 0, negative 7. That matches where I've got a y-intercept here as well. And so that's a way to check to make sure you have the correct answer. Desmos also helps you if they give you a multiple choice and they ask you which function represents the one on the graph. You can graph them on Desmos and see which one matches. All right. So example 7, the graph of function f has been reflected vertically and translated to the left by 6 to create a new function h. What is the equation of h? All right. So it doesn't specifically say that this is a quadratic function. All right. It just tells us we've got the original function f and we've made a new function h. So when I write my function, I'm going to make sure I use both h and f in this. So we'll have h of x equals, and let's look at what the changes are. We have reflected vertically, so that means I need that negative out in front. I have translated to the left by 6, so that means inside my parentheses, I've got my f, and then inside the parentheses, I need x plus 6. And then since I'm using f, I'm not putting that little squared. And then that's it. That's the only transformations it listed, was just those two. And so I can test this out with my quadratic, even though it doesn't say it's a quadratic. And it doesn't matter that we have a g instead of an h. And I'm going to put negative f parentheses x plus 6. All right, and we're going to see if this did what it was supposed to. So we can see it reflected vertically compared to the red. It's flipped over. And it has shifted over to the left to negative 6. So this is the correct function. So we are done with that one. So make sure when we're going through these, use Desmos to help you. It will help you make sure that you're writing your rules correctly.